Now let's take the very first question. Here it said that the number of ways wherein 9 different toys that can be distributed among 4 children belonging to different age groups such that the distribution among the 3 elder children is even and the younger one is receiving one more toy. So if we just forget about the 9 different toys, we just want to figure out that how many each of these elder children will be getting and how much the younger one will be getting. The younger one is getting one more toy. Clearly, the sum of the toys which all these 4 people will be getting is 9, right? The elder children are getting even. The only way wherein this can happen is that each elder child should get 2 toys and the younger one should be getting 3 toys. Correct? So what we should be doing here is that let us select the 3 toys which the younger one is getting. This can be done in 9C3 ways, right? For each selection which the younger one is getting, the rest of the 6 toys they get evenly distributed among 3 children. Since the toys are different, we can say that this can be done in 6 factorial divided by 2 factorial whole cube. Why? Because all the 3 are getting same number of toys. So this is how 6 different toys are distributed among 3 children, each getting same number of toys. This is for each selection of toys which the younger one is getting. Correct? And the number of ways wherein the number of ways wherein the younger one is getting is 9C3. So the total number of ways of the distribution for all the 4 children will be product of these, right? Now this kind of option is not given, so we need to do some simplification here. So this is nothing but 9 factorial divided by 6 factorial into 3 factorial. Here it is 6 factorial divided by 2 factorial whole cube. So this will get cancel out, and clearly we'll be getting option 3 as the right answer. Slightly difficult one, but yes, it can be attempted provided you have a good clarity that how different things are distributed among the groups. Now let's move to the next question. Here it says that there are 10 red balls and all are different, and 9 green balls, and the green balls are identical. Then the number of such arrangements are that no 2 green balls are together in a row. So if the red balls are say R1, R2, R3, so and so forth till say R10, then we can say that if they are arranged or put in this particular order, then the gaps will be used to put the green balls, because if we want to ensure that no 2 green balls should be together, then there should be at least one red ball between any 2 green balls. Now the green balls are identical and the red balls are different. So the number of ways wherein we can place the green balls would be 11C9. Why 11C9? Because there are 11 different spaces which we can identify. Now for each selection of these spaces, these arrangement of R1, R2, R3, R10 can be done in 10 factorial ways because they all are different. So this should be the answer. So on calculation, I believe this should be equal to option 2. Now let's move to the next question. Here it says that when 3 positive integers a, b and c are multiplied together, their product is 100. And the way these a, b, c are is that a is less than b and b is less than c. So c is the largest, a is the smallest. So in how many ways we can choose such number? So we need 3 numbers, their product should be 100. So obviously if a into b into c is equal to 100, we can clearly say that all a, b and c must be factor of 100. Then only it is possible, right? So let us list down all the factors of 100 starting from 1. So 1 will be there, 2 is there, 3 will not be there, 4 will be there, 5 will be there, then 10, then it will be 20, then 25, then 50, then 100. These are the factors of 100, right? A being the smallest, so let us start with A. So if I take the value of A to be 1 and the value of B, if I take it to be say 2, then the corresponding value of C would be how much? 1 into 2 into C should be equal to 100. So obviously the value of C would be 50. This is the only way wherein we can get the product as 100. Next, if I take the value of A to be 1 and slightly increase the value of B from 2 to the next factor, which is 4, then 1 into 4 is 4. So the value of C would be equal to 25, which is available here. Next, A is 1, B is equal to 5. So obviously this is 1 into 5 is 5. So the value of C is equal to 20 will suit this product. Next is if I take the value of A to be 1 and B to be the next factor, which is 10, then here we can see that the value of C has to be 10. But C has to be the largest. So definitely this combination is not valid. Now we have tested all possibilities where the value of A is equal to 1. Now let us take if A is 2. In that case, B should be greater than A. So the smallest possible value B can take is 4. So 2 into 4 is 8. And 8 is not a factor of 100. So obviously will not be getting value of C. So we can change it and make it 5. So 2 into 5 is 10, right? So this will make it 10. So the value of C should also become 10. So this is another way. Next, if the value of A is 2, the B is 10, then the value of C again will be less than B. So we can say that if value of A is 2, then this is the only possible combination. If I increase the value of A from 2 to 4, then the value of B, the smallest I can take is 5. So 4 into 5 is 20. So the value of C again will become 5, which is less than, which is not greater than B, I would say. So again, this is not possible. So from here, we can be very certain that no further combination is possible. So the four combinations are 1, 2, 3, and 4. So the answer for this question is 4. Now, the fourth question here, it says that the number of ways wherein three men and their wives can be arranged in a line such that none of the three men stand in a position that is ahead of his wife. Now, such question can easily be understood if we can ignore the condition. The condition is that no man should be ahead of his wife. Let us first of all ignore this condition. We have three men and three women or their corresponding wives, right? So the total there are six people. So irrespective of the condition, the total number of ways wherein they can be arranged is 6 factorial, right? Now let us assume that say M1 and W1, these are husband and wife. They are the part of these six people. So obviously in this 6 factorial ways, there'll be half the time wherein M1 is ahead of W1 and half the time W1 will be ahead of M1, right? Because there is no conditions for M1 and M2 that M1 would always be, but we want to take that case wherein M1 is not ahead of W1 or W1 is ahead of M1. Then we can say that will be half the chances. So it would be divided by 2 factorial. Correct? Similarly, in all the 6 factorial ways, M2 and W2, they would be arranged into factorial ways, half the way wherein M2 would be ahead of W2 and half the way wherein W2 is ahead of M2. So again, from the remaining, if I take half, then we'll be getting a case wherein M2 is not ahead of his corresponding W2 wife, right? The last M3 and W3, the same logic if I apply, then again I have to divide it by 2 factorial. So this would be the number of possibilities. So option 4 becomes the right answer. Now the fifth question says that the number of different signals that can be sent with 3 dots and 2 dashes are. So say these are 3 dots and these are 2 dashes. The number of ways wherein we can arrange this set will create different signals, right? So if all of 5 are different, then it is 5 factorial, but 3 among them are of alike, so it will be divided by 3 factorial. Similarly, 2 of them are of same kind, then we have to divide it by 2 factorial. So effectively this is 10 and that becomes the right answer. Very, very simple question, and in elementary knowledge of PNC will help you to solve this easily, right? Now let's move to the next question. Question number 6. Here it said that the number of different words that can be formed using all the letters of the word Deepmala if two vowels are together and the other two are also together but separated from the first two. So here what we can do is that we can just take up the consonant. So it is D, then P, then M, then L, right? And here the gaps are 5. So there are 5 gaps. What we can do is that we can club two vowels together and another pair of two vowels. Since they have to be put together, we'll be bundling them and we'll consider them as one. Now, if I want to figure out where these two bundles of vowels go, then I have 5 places and we have to select 2 places for that. So that can be done in 5C2 ways, right? Now for each selection, what we can do is that these vowels, that is E, E, A and A, if I want to arrange them in these 4 places, right? Here 2 means 2 bundles. Each bundle contains 2 vowels. So obviously the number of places will be 4. So for these 4 places, these can be arranged in 4 factorial divided by 2 factorial into 2 factorial ways, right? So the number of ways would be what? This divided by 2 factorial to 2 factorial. This is how the vowels can be placed and arranged. But the consonant can also be arranged, right? So again, we have to multiply it with 4 factorial. So this should become the right answer. So let us simplify it. So this 5c2 is nothing but 10, right? This will become 6 because this will go by 3 factorial, and this becomes 24, which comes out to be 1440. So this becomes the right answer. Now let's move to the next question. Question number 7. Here it says that in a unique hockey series between India and Pakistan, they decided to play on till a team wins 3 matches. The number of ways in which this series can be won by India if no match ends in a draw. So if the match ends when any of the team here in this case will be favoring India, that India wins 3 matches, then the series will be over, right? So the minimum number of matches required is 3 because somebody need to win 3 matches. Then only the winner can be decided, right? And the maximum number of matches would be 5, correct? Wherein one of the team is winning 3 and the other team is winning 2 matches, or we can say that India is winning 3 matches and the Pakistan is winning losing 2 matches. But the fifth match would be won by India. Then only the series will be sealed with 3 wins, correct? So one way is 3 wins. So obviously this is the only way where it can happen. If the series ends in 4 matches, then the fourth match will be won by India, and that will be the third win of India, right? So we can say that the fourth match will be won by India, and before that, India will be winning 2 matches, and Pakistan will be Pakistan will be winning 1 match, or we can say that India will be winning 2 match and losing 1 match. So this can be done in this way, right? Here, this three letters, that is 2 wins and loss, can be arranged different ways. How many ways? 3 ways. We can see that this will be LWL. This can also happen, or LWW something, and it could be WLW, win loss win, and again last will be win. So there are 3 ways. If the match ends in if the series ends in 4 matches, then it would be 2 win, 2 losses, and last one will be won by India. These 4 can be arranged in 4 factorial divided by 2 factorial into 2 factorial ways, which is nothing but 6. So the total number of ways is 6 plus 3 plus 1, which comes out to be 10, and that becomes the answer. Now, question number 8. Here it says that the number of different words that can be formed from the letter of the word success, in which the 2 C's are together but no 2 S are together. So 2 C's, we can bundle them, and the 3 letters are S, there is U, and there is E. 3S would not be together, right? So what we can do is that we can put the C, U, and E like this, and these are the spaces wherein the 3S would go. So there are 5 different places where, there are 4 different places wherein 3S can go. So the number of ways wherein S can be arranged is 4C3, correct? And these combination, that is CC, U, and E, they themselves can be arranged in 3 factorial ways. So overall the answer would be what? This is 4C3 is 4 into 6, which comes out to be 24. Now the ninth question says that there are 12 guests at a dinner party, and suppose that the master and mistress of the house have fixed seat opposite one another. So let us draw this situation. Suppose this is the table, right? So here is the master and here is the mistress. Now since there are 12 guests, so we can say that here there will be 6 spaces. Here again there will be 6 spaces, correct? And there are 2 specific guests who must always be placed next to one another. So for these 2 people, let us find the possibility. If they are on this particular side, then this is 1, this is 2, this is 3, this is 4, this is 5. Similarly, we can say that here again these 2 become 1, 2, 3, 4, or 5. So in either of the cases, these 2 people can can sit in 10 different. Now, in this 10 ways, these 2 people within themselves can be arranged in 2 ways, right? For example, A, B, they can be arranged in B, A as well, right? So for each of these 10 different ways of their sitting arrangement, they themselves can exchange their seat between them in 2 ways. So this is how these 2 people can sit. and balance 10 people can be arranged in rest of the 10 places in 10 factorial ways. So the overall answer should be 20 into 10 factorial. So option 1 becomes the right answer. Here it is factorial 10. Now let's take the 10th question. Here it says that in a conference of 10 speakers, S1 wants to speak before S2 and S2 wants to speak after S3. And there are 10 speakers, and other than these three people, nobody has any objection of at what number they want to speak. So we have to find in how many order, in how many ways they can speak, or all these 10 people can speak in their order, right? So what we can do here is that if we just ignore the condition, then the number of ways is 10 factorial, right? We can arrange these 10 people. But what is happening here is that S1, S2 and S3, they are arranged in 3 factorial ways, and those 3 factorial ways is already included into it, right? If I want to just maintain this particular order, in fact, let us take this order that S1 want to speak before S2. So S1 should be before S2 and S2 should be after S3. So here it could be like this, right? Or it could be S1, S3 and S2. So these are the two combination or two possibilities wherein this condition can be met, right? Here we have ignored these two conditions. If we do not take these conditions, then S1, S2 and S3, they can be arranged in 3 factorial ways. So what we can do is that 10 factorial divided by 3 factorial will give me the possibility wherein there is no arrangement, or there is only one way of arrangement, that is S1, S2 or S3, right? Or this is the possible arrangement. So for this possible arrangement, this is the number of ways. For this possible arrangement, again, this will be the number of ways. So we can combine both. For that, we have to multiply it with 2. So overall, the answer would be 10 factorial divided by 3. So option 4 becomes the right answer.